Okay, so as I was mentioning, when we have already, let's say, designed a class and we are instantiating an object here, we're saying what? This T object will be of type capital T. Again, the net is breaking. Okay, I think I got disconnected once again. So this could anyone respond to me again so that I can know if I'm audible or I have been disconnected again and again or not. Salman, Rakibul, anyone? Okay, sir. Thank you. Yes, okay, sir. Thank you, sir. So, uh, as I was mentioning, when we're saying that this T object will be of type capital T, that refers to a type. This is the new type we are declaring, isn't it? So that means user created a class which has become a type now. So that's a data type, the user defined type. User defined type. So if this is a user defined type, just a second, let me switch my network. Okay, I think now you should be able to hear me again, and I think this shouldn't fall since the internet is constant now. Okay, so let's continue. So user defined class, as I was saying, is a user defined class or user defined type. It's much more better to better sound. So user defined type, like this is then the user defined type which user already defined. Now, if you see closely, this is sort of something which we see in Java, isn't it? However, user defined type has been there ever since, like from when programming language has been invented or some sort of modernization has been produced. For example, COBOL, as well as the COBOL language, or the COBOL language. At the same time, the C itself, so COBOL and C language, both have the user-defined types like at the very prior. Now, why am I saying this with, let's say, double quotation? The thing is because if you consider, if you remember, C does not have any class object sort of relation or that sort of feature. What it has is this struct keyword, and inside that user defines some variables, and let's say it has some name. So int a char C of 10, like this sort of things, isn't it? So this is also a user-defined term. And when we define this, we simply say we have a Q, a variable P, which is of Q type. So whenever now I use, let's say, P dot A, it is simply referring to this internal variable which has been declared. I can define variable like values to it. Let's say 10. Then P C of 5 is equals to, let's say, H. Like I can write this now. So user-defined types has already been there like ever since from the time of, let's say, 1970s or 76. So let's C generated like after 70. So yeah. So unlike them or like them, Java, C++, and C# also like they also support this feature. Now, as I have mentioned earlier, that so far in three address code, when we are dealing with three address code, we have to change this. Like, how do we then change this user type to three address code? So far, we have seen, as I mentioned earlier, that we have seen branching logics like if else, while, switch cases, that sort of branching logic, which were converted to the three address code. Then the looping, which are like, yeah, while loop, for loop, those sort of things. Like we haven't done anything related to for loop, but we have worked with while loops, and though like while loops are similar to for loop. And then we did also have seen, like we have seen also the function call and jump straight statements. So, and also the assignments which have been given to you is also a function call. So you will be able to learn, or if you have gone through the section 6.9 of the Principle of Compiler book, the designing principles, you would have seen that the function calls are very similar. And we saw an example just before, like a couple of minutes ago. You have seen how function calls are like made. And in branching or control flow, we have what? Levels. We have levels. And finally, the last thing was to mention was working with multidimensional arrays. We also have seen how to work with multidimensional arrays. How was that? Like we have seen whatever the dimension is given, even if it is 100 dimension or thousands of dimensions given in array, one after another, we have to somehow convert it to a single dimension. Why? Because memory locations are sequential memory or sequential addresses. So in order to be able to understand, the memory locations are actually the processor or the system to understand what we are trying to extract or where we are placing the values in the memory. We have to convert them into a single dimensional location or single dimensional array, I mean address. Now, as I mentioned, or as we are dealing with the user-defined types, so let's work with the CS instruction again, which is basically the struct, and see how the data is actually, or the data are stored in the symbol table. We know that when integer types or any declaration is stored into the symbol table, they store the symbol's name, the type of the symbol, the width of the symbol, and the offset of the symbol. So let's see. Let's see how this happens. Let's have an example. Let's have an example. Student. Let's say student is the defined data type we are working with. Inside that, we have, let's say, int student ID. I'll be strictly following the handle provided to you regarding the OOP features. Okay. So the PDF which has been provided to you and the PDF you could find in the box under lecture 18, simply use that. So I will be strictly following that. So the examples here will be also be from there so that it becomes easy for you to go through and understand, like to make sense what is happening. even if you like sort of miss the online class. So you have the next one is float CGPA, and then we have int, let's say the batch, or simply referring to which batch student, and finally we have a character type array, which is named as full name, let's say, and it ends. So now, if we try to translate this into a symbol table, the symbol tables will store the wait, yeah, the symbol table will store the values in this part, in this manner. So let's say this is the table, and here we have the name of the symbols. Under this, we'll be having name of the symbols. We'll be having the type of the symbols. Then we will be having the width of the symbols. And finally, we'll be having the offset of the symbol. So let's see one by one what happens. The first one is student ID. So the name here I'm writing student ID. What is the type of the student ID? It's given integer, so integer. What is the width? Width of integers are 4 bytes. And offset? Offset means from where in the memory location has it started. It's like incrementation. Now, we don't know whether there was anything before this or after this. We have no idea. Let's say this is the starting of the source code we have provided it with. If that's if that's the case, and at the same time, if like even if it wasn't the starting of the source code, whenever we have a curly brace, that means what, we start a new block. So this is a new block, isn't it? And whenever we get into a new block, where like how do we start the offset value with? We start with 0, because we have previous, like even if we had some previous source code, like above the struct, there are some other declarations and functions written, and it has some offsets already preserved. We have already stored the value to be preserved in the symbol table or in the stack. So once we have stored them, now we can again set the offset value to 0 for this scope only. So that we can start counting the values or the offset values starting from the very first element inside this block. Hence, we are starting with offset 0. So we are writing here 0. Now the second value is float CGPA, which is CGPA. I'm writing here CGPA. The data type is float, and we know the width of the floats are what? 8 bytes. Now, one thing to mention here, if we have started this from the 0 number position, so let's consider the memory location here. Let's say this is the memory. This is the memory. If this is the 0 number position from where we started, now the width of this data or this variable is what? 4 bytes. So obviously it will cover up these 4 bytes. This is the 4 bytes. So the next possible value could actually be placed after this 4 bytes. So that means the new offset, the added or the new offset for this CGP will be what? The previous offset plus the width of this previous data or variable or identifier, and we get the new offset, which in this case will be 4. If that's the case, we can see a pattern here. 0 plus 4 gives us 4, and the next possible offset will be what? 4 plus 8. The previous offset, with that we will add the width of this variable, and we will get the next offset, which in this case will be 12. And the next value is basically batch here. So batch is the next name or next symbol name, and the type is again integer. And what is the data type or data width, which is integer? That means it's again 4. And the next offset value will be 4 plus 12, which is basically 16 here. Now, the next one is a bit interesting. Now, I've stated so far in the class that the character types are of 1 byte. Like it depends on the architecture and the programming language which we are using. In this case, it is given as 2 bytes. So we will work with 2 bytes for this one. So here, let's say the full name is the name of this symbol. So full name, and the next information to store here is the type. What is the type? If you could see, we could have simply written character here. We could have simply written character here. But however, when we get to retrieve the information, at that moment, let's say we are generating the free address code, or we are reconstructing the like reconstructing the source code, we will be in an error. Why? It will see this type is character, and it will simply write this as this character, full name, and it will go on. So there's this error. Why? Because now it is not recognizing this as an array. So what to do? Remember in the class lecture, I have mentioned how to declare the array types. There is this function for array construct. Inside that, we will simply write the number of elements inside that array. So in this case, it is what? 20. And each of them are what? Character type. So this array type is basically this whole array of 20 elements. Each of those elements are character type. Hence, the type will be basically array 20, and the elements of each of those array are of character type. Remember, I'm writing three address code. What did we use? So if someone was in L1, we would have written L1.array, and after that we would have written this element. This element means each of those elements. What are their types? So in the case of character array, each of the elements. So let's say this is the character array of 20 elements. Each of them are of what? 2 bytes, and 2 bytes correspond to whom? Character types. Hence, each of the elements are of character type. So, if you have received the information, now when I declare the class, let's say, I'm sorry, when I declare, when I instantiate an object, what do we get? Let's see. So, let's say we have the struct value. Oh, wait a minute. Struct student is written here. So let's say I'm declaring a variable, so student, and I'm saying that the name of the student will be Adam. So I'm declaring now the student with the data type, user-defined data type as a student. I'm declaring this name as Adam, like this is the data. I will be storing a value or a data in this variable, and the type will be student type. Now, when I place or when I write this instruction, Adam.cgpa, this basically correspond to this element. So now Adam also has all those possible elements, isn't it? Now, if I had, let's say, another one, student Bob, Bob.cgpa would have been given me a CGPA value because Bob also has the same structure. However, both of the CGPAs are not same, isn't it? Because they have now separate memory locations. However, they follow the same structure. They follow the same structure. However, they are on separate memory locations. Now, if that's the scenario, that's the case, let's work with Adam again. Now, if I assign a value, let's say 3.85, with due respect to everyone, I'm not insulting anyone or anything. This is just a hypothesized or randomized value. Let's consider a 3.85. So, if that's the case, in that scenario, what will be the allocated or actual logical address? So the equivalent logical address will be given as this Adam will be onto some offset value, isn't it? So the offset value is, let's say, given as this @ Adam. Remember, for every scope we get into, we start with a new 0, isn't it? So let's say onto the memory location, the logical address started with this Adam. If that's the case, now where do we place this value?
See here, this CGPA was on which element on the symbol table? This is on the second element. And second element, offset value started from which value? 4. Hence, we started from this, or we place this 4 here. That means starting from the starting offset, we are now taking the CGPA value. So if you consider the memory, so the memory location will have 1 byte, 2 byte, 3 byte, 4 byte. 4 byte was addressed for student ID. Then we had 8 bytes, 1, 2, 3, 4, 5, 6, 7, 8 for float. So these were for the student ID, for student ID. And then we have this for the CGPA. And then we have some, let's say, integer value for or the best the best number. And finally, we have the array for character. Now, this CGPA started from offset of what? 4. Hence, since this is the memory location given to Adam, the starting of this address is basically given as, let's say, @Adam. And when we insert into this square braces a value 4, that refers to the second element we are referring to, which is in this CGPA, since the offset value is starting from what? 4. So this is how things get translated for user-defined data types. Now, what happens for sorry. So for the scenario of character data types, let's see what happens. So let's say on the character array, I'm taking like the character array has been already, let's say, like some values has been placed inside the character array, and I am taking, or I'm going to say the value inside the character array and the value which is inside the 10 number index. So CH, I'm extracting the array which name is full name, and I'm simply placing whatever the value was on the 10 number value to this CH. That means if that's the memory location for the character type, and this is the first of the character type, and it goes on, so I'm requiring the 10 number element which is stored in the character array. Now I need to convert this into what? The memory unit, isn't it? Like this is the array. This is the array of, let's say, how we define in the high level code. This is index 0, index 1, index 2, index 3, index 4. Like this is how it goes. However, we have to convert this into what? Sequential memory location. And based on like offset calculation. So what happens? Let's see. At first, what we will do is we will take we will take the location of the array. So the location of the array is, let's say, given here, which is inside which location, which offset? 16. So this is the 16 number offset. So let's bring that 16 number offset location at first. So the whole, let's say the whole element or this whole memory location is named as what? @Adam. So the first or initial offset we get as @Adam. And on which position is the character settled? It is on the 16th offset. So we get now, let's say, the character type arrays, the very first offset value. So from there, the offset or the character array actually starts or started. Now, how to now get the 10 number element? In order to get the 10 number element, what do we have to do? Remember, we get to the values as bytes, isn't it? Whatever instruction, like whatever width or whatever offset we are calculating, it is based on what? Each bytes. However, the character values here given is elements. and each element, there is 20 such elements, and we are requiring the 10 number element. And each element is of what? 20 number, like 2 bytes. Hence, we have to convert this element number into the equivalent byte format. So 10 elements means what? Or 10 number elements means what? Starting from 0, each elements are of 2 bytes. Hence, 10 number elements in 10 times 2, which is in 20th byte. So we will go to the 20 number byte of this T1. Why T1? Because T1 is in 16 number offset. So this is the T1. So this is, let's say, kept in T1. And from T1, we are going 20 bytes to the right and taking whatever value is placed there and placing it into CH. Now see if it makes sense or not. For this character type array, we're going to that array's location, which is stored in the 16th offset. And from that 16th offset, we are incrementally going to the 20 number position where the 10 number index is residing. So again, if you see, this is the 16 number position. So we are directly going to 16 number position using this. So here now T1 is staying. And from there, we are demanding for the 10 number index value. Now each elements are of 2 bytes. Each are of 2 bytes. Hence, 10 times 2 is basically 20. So we're requiring whatever value is on the 20th byte of this array. Remember, 20th byte of this array, not this whole location. So 20th byte from starting at 16, we are requiring the 20th number bytes value. Okay? So that is how the normal structure or user data types are being converted to. Now, let's see an example how, let's say, inherited or multiple data types are, or nested data types work, or inherited data types work. Not actually inherited. I will be wrong if I say inherited, because we are not inheriting. Rather, we are having some already defined user data type into another user data type. So let's see how it works. Okay, let's see here. Okay, so let's say at first we have a course and a teacher, like each of the course, like let's consider in the perspective of the courses we have in our university. So you have courses and each of the courses have some instructor, isn't it? So instructors are whom? They're of teachers. So let's say we have a teacher data type, struct teacher, and each teacher has some employee ID, a character initial or character type of initial. So now each lecturer have an initial, and then character type array of 20 elements where we store the name of the teacher, and finally the position of the teacher. Like, are they lecturer, assistant professor, associate professor, or a professor, or distinguished professor, or dean, or head of the department, whatever their position is, we'll be storing them in a 15 elements character type array. That will be basically the position. That's one of the, let's say, one of the data type. Another is the course we are defining. So struct course, and each course has a course code, and they have a name, course title basically. And finally, they have instructors. Now I'm saying the instructors are basically teacher type. Instructors are what? They are of teacher type. Okay. Now, let's say in the case of CSE 420 course, we're working with, let's say, CSE 420 course. If that's the case, then what do we need to do? We have to at first say we have a course CSE 420, isn't it? When I say this, then I get the data type of this CSC force course. Now, let's say there is only one CSC 420 course, like one section only, and that has a specific structure. Let's say in our case, it's Yanhan answer. So if the answer is the instructor, now I want to know the initial of the answer. So how do I do that? Simply, I say CSC 420, because this is the course, and on which part do I get the instructor's information? In this instructor variable, isn't it? So CSC 420 dot, I get access to the instructor data, and inside that instructor, we get all of these variables, and we wanted to know the initials, so simply place a dot and say initials. That will give us the initials of the course instructor. Okay. Now, if that's the case, then how how is this converted into the original memory addresses or the three address equivalent? How is it converted into? So let's see. Now, when we have such structures, multiple structures, remember, for every structure, there is what? There is a symbol table. So at first, let's do for which one? Course or teacher? Now remember, course has a teacher inside itself. So we have to, at first, prepare the teacher symbol table initially. So let's see what the teacher's one will look like. So we will have the name. This is the symbol table for teacher. Then we have the type. Then we have what? Width. And finally we have what? Offset. So the first one is in this case employee ID. The type is integer. The width is 4 bytes. And since this is into a new block or inside a new block, we start from 0 number offset. The second one is basically what? The second one is initial. The type is basically what? Now you tell me. One of you kindly tell me what will be the type now. Anyone? Exactly. Very good. Exactly. Very good. So array 3, comma, what? Star. Exactly. Character. So this is the initial type. And the width will be what? Remember, characters are of now 2 bytes. So 2 times 3 is basically 6. So 6 is the width. And what will be the offset? Anyone? Exactly. Why? Previous offset plus the previous width, we get the new offset. So 4. The next offset will be 4 plus 6, which is 10. The name of this data type or the identifier is basically name. And this is again an array type of 20 elements and of character type each elements. Now what is the width? Again, 2 times 20, which is 40. Now, if this is 40, 40 plus 10 is 50. So the next offset is 50, starts from 50. And then we have the position. The type is again array type, 15 element. And character type data type. And we have width. In this case, 2 times 15 is 30. Okay. Now, if there was other offset values or subsequent offset values, we would have stored it. So whatever the next block or whatever comes, simply it will start from where? It will start from 50 plus 30 equals to 80, isn't it? It will start from there. Okay. Now let's go to the symbol table for the course. So for the course, we will have code, name, and instructor. So let's consider for the code. So let's have another symbol table for course now. It will have name, it will have type, it will have width, and it will have offset. The first one is code, which is basically course code, and it is of integer type. Remember, whenever we have a new block, we have a new symbol table, and we start from where? Start from a new offset or zero offset value of 0, because we store the previous offset value into the stack. So this offset is starting from 0, and the width of integer is of 4 bytes. The next possible offset will be basically 4, because 0 plus 4 is 4. The next name is the name. The type is array of 20 elements, each of character type. And now what is the width? So 2 times 20 is 40. What is the next offset value? 4 plus 40, which is 44. And now, what is the name? It's given instructor. If it is instructor, what is the type? Now see what a thing happens. It is of teacher type. So let's consider this as a teacher type. And what is the width of this value? Now the width is basically what we have calculated here. So this is what? 80. The total width is 80. Okay? So that's how it works. Now, this teacher, like basically this won't be actually teacher. What will pass here for this type is basically the table we generated for the teacher. So when I write here teacher, it is basically saying the type is basically this whole symbol table. It passes the reference to the symbol table. Okay. So when I write here teacher, it doesn't actually say a teacher type normally. It says this whole symbol table. Why? The structures, they themselves do not have any data type, isn't it? Structure, like if you have a certain structure of this format, let's say struct t, and this offset will be 0 and the width will also be 0. Why? Because inside there is no offset, like no elements. Hence the offset is also the width is also 0. If something, the width of something is 0, then that still cannot be a data type, isn't it? So when there is something, then it is a data type. Hence we pass the whole symbol table as the data type, or the type in this case. Okay. Now we want, like as I mentioned, we are requiring the initial of the course instructor to be provided with. In this case, CSE 420 is given, isn't it? So let's try to convert this into 3-address code. So CSE 420 refers to, like, how do we get the offset value of CSE 420? Simply using this @ and we get CSE 420. We're getting now to somewhere. So this is the offset of this, or the starting offset of this CSE 420, the course CSE 420. Now, on which offset does the instructor symbolize? On the 44 offset, no? 44 number offset. So we write here 44 number offset because we are requiring that instructor. Simply saying this is referring to which variable, the third variable or the third identifier. Now the third variable is basically settled at the 44 number offset value. Hence we say whatever is settled on the 44 number offset or 44th number byte, simply provide it to me. So let's say that this is the instructor. We could have also written here as, let's say, A. It's fine. We can have written here A or I, whatever we want. So this I is the instructor, let's say. Now, when this is being said, it simply gives me the offset starts from this portion. So the symbol table is now for the teacher. So when I have reference to this I, it simply points me to which location or which part of the symbol table, to the ith symbol table. So if that's the case, I have received this I can a bit like in your like we can do this as well. So whatever we are wanting, so let's say over here, the I starts from this offset, and on which number offset of this I is this initial placed. So on the teacher symbol table, the offset of initial is placed on 4 number. So I of 4. We can write it in this format, it's fine, but in your the handle it is given as the temporary variable. So let me replace this with the temporary variable. It will be coherent with that. So T1, and so we will be getting here a T1. So T1 variable, the T1 variable is basically holding the starting of this symbol table. So it is at the 0 number offset, or not actually 0 number offset, it is starting from this 44 number offset. So on that 44 number location, we will be having, let's say, this teacher symbol table. Okay, so if that's the case, so we are on the 44 number location, and from that 44 number location, we want the 4 number offset. So from, let's say this is the memory location, this is the 44 number offset value, and from this 44 number, we want to go further 4 bytes. So this is added 4 bytes. This is what it represents. Okay, and that value should be placed into the initials. Okay, so this is how the nested data type or nested user defined data types actually work. Okay, fine. If that's understandable, then let's deal with how or why or what are public, private, package, protected, visibility, or simply the visibility control. Now, what are these things? Now, if you remember, while doing the lab work, we faced or we worked with the specifiers, so the visibility controllers. Now, what were those? Simply when we have a public written before the functions or the classes, or it could be the variables, it is accessible from elements from other files, isn't it? So that's what public refers to. Now, private refers to that this function, like if there is this, let's say, function written as private in static void, like this sort of thing, and in that case, only from this object itself, this private, this function or this variable will be accessible, not from some other classes or objects or files. Then we have, let's say, packages written out. What are packages? Packages are basically like in terms of, let's say, Java, we had this packages or the package keyword. That basically refers to, it is of this project. Inside this project, we have this package or the bundle of, let's say, files, and this is under this package. And finally, we have, let's say, the protected. Protected simply is also another type of visibility control. That means it is protected and cannot be seen from some other like another part of the file. So that's basically what they're referring to. Now, as you have seen earlier or so far, that the intermediate representation basically is very simple. So simple that it cannot have such public, private, package, protected, like these sort of keywords. These are very high level things, like high level in a concept of, in the basis of user defined term. When semantic analyzer does the semantic analysis, all of these visibility controllers get ignored or does not exist. Like they're like totally forbidden or they're actually discarded. So it is inside the symbol or semantic analysis where the compiler actually makes sense which portion of the variables or which portion of the classes functions are accessible from other existing portion of the source code. So let's say this is one class and this is another class. So these are two classes. So the protected items from this class are not accessible from this class, even if I create an object. If that's the scenario, these are resolved in the semantic analysis. Once the semantic analysis phase works, again, everything gets converted to those simple instructions which we have seen so far. Okay. So that's basically the transition for, or the phase which is semantic analyzer. That's basically responsible for discarding or ignoring the visibility controller after making sense like which which portion which portions which portions are accessible from other portions or other parts. Okay, so this is what semantic analyzer does, and basically that's the portion where this visibility controller ends. Okay, there's nothing to realize here, or there is nothing to do here. Like this is the same thing for the keywords final and constant you see in the high level code. So these are like controlled or mitigated in the semantic analyzer. Here, nothing to see. Like we cannot like do anything here. This is like a very theoretical concept. Okay, now, as I mentioned at the very beginning, in the class there are some methods which are known as class member functions, isn't it? Because they are members of the class. Now, how to deal with them? So let's see an example. We have public. Again, this is the visibility controller, and this gets ignored in where? In the semantic analyzer case. The public class student, and inside that we have private integer type ID. Like these are the class variables, and these are private, only accessible from this inside this class, not from outside this class. Private, like I cannot even access them whenever I have the objects also. Okay, so these are like only accessible from any of the functions or any of the methods we declared inside this class. The private string name and private list. So what we will be doing here is basically we will be creating a student class, and in the student class, like each student class simply represents each student. So we will be having objects regarding this student class, and there will be this ID, there will be this name, and there will be the GPAs they have gained so far in each of the courses. So the GPAs are of like stored in this list, which is actually array, and these are the semester GPA, semester GPAs. And now we will be seeing whether the student is in probation or not. So public Boolean. This will simply return as a Boolean value, true or false, 0 or 1, is in probation is the function name, and the inserted value is basically float of the threshold CGPA. So there is a threshold based on which we will check whether the student's CGPA is less or more than this. So float threshold CGPA. And inside the function, there are some local variables. So these are global to this class, and this parameter is inside the parameter scope, and these variables which will be declaring now, they're basically inside the local scope of the function. So float GPA sum now for each of this element inside this semester GPA. So for each sem GPA in semester GPA, again I'm saying this semester GPA is basically a private or private visibility control. Like it has a private visibility controller. So the data could only be accessed inside this class only from any of the functions. So inside this function, I can simply use this data types or the data is declared here. The semester GPAs, and with that we do the calculation of GPA sum plus equals sem GPA. So each element we are adding, we are calculating the total GPA, and then we calculate the CGPA. Now we will check whether this CGPA is greater than or less than equals to the threshold CGPA. So if this CGPA is greater than the threshold, so the threshold is threshold CGPA, then we will return false, meaning no, the student is not on probation. Else return true. Okay. Once we're done with this part, we can simply close the parentheses, the right curve, and finally do our calculation. So now we have a class here, isn't it? We have a class here, and inside that class, we have what? A function, which is a member function. Now, how to call this member function with respect to classes? Because we have seen the symbol tables are basically of each of the each of the types, we can say. So each of the classes, as like the structure data type, the classes will have symbol table for them, isn't it? However, how to be able to call each of these functions? Because if you recall, when we declare or when we instantiate an object, so let's say, sorry, not class, let's say student, we are instantiating a student of a student or an S, which is of student type, equals to new student. When we call the is in probation function, how do we call that? S dot is in probation. We call it in this manner, isn't it? And place the parameters here. But you have seen so far, when we convert this into 3-address code or intermediate representation, we do not have any longer this sort of dot sort of thing, isn't it? So how to then convert this into an equivalent shared code? And how does member function basically work? Like what is the magic behind this? How to call them then? Okay, now remember we have so far, if you observe here, we have a threshold CGPA which is inside the parameter. So this parameter has a scope, which is basically the global scope. So this is the parameter scope. The second one is, if you see here, we have a GPA sum present here, we have semester GPA here, and we have a CGPA here. So these are the variables declared here, which are of what? The function body's local variables. So this is inside the local scope of what? This functions body. And finally, we have what? The semester CGPA, which is in the class scope, the global scope of the class. So this class scope. So this is the scope for class. So inside the class, we have the semester CGPA. We're not working or like these are also on the class, like the classes scope, but I haven't mentioned them here because we are not using them here. Like they're there for the like for the purpose of the attributes of the class. But what we are using in this example is basically semester GPA. So that's why I mentioned that only. Now, how do we convert this into normal methods, normal functions, rather than member functions? So the modifications that needs to be done is basically here only. So focus on this part attentively. Changes which is basically needed to be made is only onto the function, nothing else. What will happen is basically this will be the function itself. There will be no changes made here. Okay. There will be no changes made here. What will change is basically, can I copy this part? Let me see, because I will be requiring this. Let's see if I can copy this or not. Um, yes, I can copy this part. Okay, okay. That's a good sign. So the changes will be basically here. If you focus here, in the function, we have so far here. The function is so far here, but in order to get rid of that or make or implement the function as not the member function, or how to be easily or how to make this easily implementable in tree underscore. What we will be requiring here is we will normally declare this function here, which is normally declared. No classes declared so far. Observe here, we have only just declared the function here, but I have to mention that this is a certain object. Now, which object or which class? See what changes I make. We will change on the parameter. So the parameter, obviously the parameter which was the threshold CGPA that will be there. However, now there will be a first parameter. That means there will be now two parameters. The first one will be the class object. So the class object in this case was what? We were passing a student type. So, or this class or this function was basically inside what? The student class. Hence, the first parameter will be that whenever I call this function is in probation, I will pass as the student, I will pass the student here, and let's say CGPA 3.5 and call. When I do this, it will simply understand, okay, this function is basically of this class or of this object, which is a student class type. Okay, so we'll be passing the student type here. So student, not student, it's student. wait, where? So student, that's a student, and then this keyword. If any one of you have used the Java syntax of the Java programming language, you would have been familiar with this keyword. So this refers to like this object. So this is basically the parameter as student this, and we have float threshold. This when we are simply using this keyword simply refers to when I'm calling this function and passing a object here, it is referring to the object we're passing. So whenever we have, let's say, this keyword, so this dot CGPA, this refers to that object's CGPA. Okay. This is the same thing as, let's say, having, let's say, student type X. So X dot CGPA is basically CGPA X, the CGPA of X in this case, okay, or Y. So that's basically it. And the second keyword, the second parameter was threshold. Threshold CGPA. This is one of the like major modification. And the second one is over here. It will be no longer semester GPA. Rather, it will be this object's semester GPA. Semester GPAs. And we're done with this portion. Now let's see, see this function is like no longer inside a class. Rather, this is just like any normal random function. However, the first parameter we are passing is basically the object pointer, referring to it as that this function is basically should be inside this object or called from this object only. Similarly, when we are using this dot semester GPAs here, this also refers to that this is no such ordinary GPA. Rather, the object we have passed here, student this, it will have a symbol table there. Inside the symbol table, there will be, let's say, the name, the ID, the semester GPA. So this dot semester GPA basically refers to this third identifier. And we know how do we convert something dot the variable into 3 code. How do we convert it? Simply passing, let's say, this at this and by placing the offset value inside, isn't it? Similarly, we would have replaced this semester GPA in the same manner. Okay. So this is how we actually modify the member function from any object. Now, once we call this, how do we call actually? So this will be called in like whenever we are calling this in like is in probation function. How do we call this? Let's see. So we'll be calling the return type is of what? Boolean type. So we'll be returning or getting some Boolean values of Boolean. Let's say the value is either probation or not. So probation, and we'll be calling this value which is wait. So in normal situation, how would we have called this? We would have been declared, let's say student, let's say student A equals to new student, like in normal case, a normal scenario. And we have, let's say, some like statements where we declare or where we assign the values inside the student A class. And then we call the is probation function as well. So student A dot is probation is the normal convention how we call this, isn't it? And finally, let's say some threshold here. So let's say 3.00. Now, this will be converted to this format. We will again have this Boolean return value. However, now no longer we will be placing student A dot is probation. Rather, we will be directly calling this is probation and passing the student A object. Student A object as the first parameter and the second parameter as 3.00. Okay, so now this line gets executed here or passed here as a parameter. So that simply does our does our work. That is how the trick happens, isn't it? Like, is it like, don't you think like this is like fascinating? We write such complex class object sort of function or object oriented programming, still they get converted to singular like execution unit or single liner instruction. Okay. Now, if that's understandable, then the main portion of today's lecture is basically this part where we will be working with the polymorphism. Now, how does method polymorphism work? Now, method polymorphism is basically what? It's basically overriding a previously written method. So let's say we have this class person, and that inside has, let's say, class person. It has, let's say, string name. Let's say name is given as n. Then let's say int as id. We have string address and age, and we have some member functions. So string get name, and get name will simply return the name or return n here. In this case, the name is represented as n. And then we have, let's say, string get description. This is the last part of this lecture. Inshallah, by after that we will be like, done with this portion. So string, let's say the description is basically equals to the name, which is in this case n. With that we concat, comma, that would concat simply the address. And finally, return this code or this string. And we have, let's say, another class which simply extend this person class. Extending person class means means what? Simply it will also inherit whatever is placed here. Whatever is placed here, it will be inherited. And with that, we will also add some additional attributes. So let's say in this case, string department. Then we have int student ID. Besides the NID we already have. Then we have now, let's say, string get department. And we will simply return whatever department is. And finally, or before this, we have the int get student ID. That will return us the student ID. So return student ID. And now finally, we have, let's say, string will override this. So morphism is happening, polymorphism. So string get description. We although have inherited this description, but we are overriding this description And now we have this string description as n or name. Now this n is like, see here, we haven't declared n here. However, we have inherited this n, hence we can use that n over here. So the n concatenated with comma, this concatenated with student ID, which is described here in this class. Finally, concatenated with comma and concatenated with department. And then we just simply return the description. Pardon for the handwriting, but I guess you can understand. Now, how do like this polymorphism works? Like, since this is, let's say, inheriting or extending, so inheritance means what? If inheritance is working, then this class should also point to this description. This class should also point to this n, this ID, like it is inheriting these values, isn't it? This name, like it is inheriting, like simply inheriting the values. So if this points to this get description, then how do this get description works? Or rather than executing this get description, how this get description is executing, like how things work. So in order to do so, we at first need to do what? We simply, like, we know how this member function gets converted to what? Gets converted to the non-member function. We just saw how. Let's do that at first. So I won't be writing the body part now. I'll be just simply writing what the function will become. The first one will, this string get name will become what? The string will be having get name. However, this will be this will pass or require as parameter what? A person class. So person and this. Okay. The second one, like I'll be no longer writing the body part, so it will consume a lot of time. So I will be just simply writing what will be converted into. The second one will be string get description. Again, we will be passing the object instance. The third one is here get department. Like these are the normal function it will be converted into. So get department. Again, person object instance. String get student ID. Passing person this as parameter. Finally, this will also be generated. Now, the question is, which one to execute? This one or this one? Like, how does it know only, like, execute this one rather than this one? That's our question. Because we know every of the function declared, they will be they will be generated in this manner. The function, like member functions, will be generated in this pattern. So, person, this object again placed, but however, how this will be like generated or converted into, like which one to execute. Now, this one, the class here is basically what? The student is basically a subclass of what? The person class, isn't it? We do know what is happening in polymorphism is basically what? It is basically overriding. The overriding is happening. However, what the compiler does is basically generate a table, which is better known as V table. Okay, so the compiler basically generates the V table for each of the class entries. So in this case, for example, the class person, for the class person, it will have these variables, identifiers. So the first one being, let's say, the string name or string n. Then we have the integer ID, which is basically the NID I have mentioned here. So I'm shortening them as much as possible. Then I have string address, I have int age, and the last attribute, as I mentioned, there will be a vtable. Now, basically, it will generate a vtable. Vtable, however, we won't pass this vtable completely to this quotient. Rather, we will be having a pointer. It will be basically a pointer. This will basically point to this vtable. So in this class is basically in the same manner, it will generate tables. Tables are symbol tables. So as like structure, classes symbol table will be generated. Each of the entries will be, let's say, this case an, which are of string type or basically character array type. Then we have id, which is of integer type. Like this will happen as the structure in the structure pattern we have seen. And with that there will be this additional pointer, which is basically integer type pointer, which will contain the reference to the vtable generated. Now, what will the vtable contain? This vtable will simply contain the name of the functions. So for this class, which is the class person, the two functions which were introduced or written here was basically get name and get description. So the first two. So get name and get description. These will be the two entries. The pointer points to this table, and the vtable consists of get name and get description. However, this get name will basically point to a function which is, let's say, string, which is basically this one. This get name points to the function which is get name. So this points to, let's say, string get name, and we pass person this. It simply points to this functions table, or the functions table, and the function table is basically a scope table for that function. Okay, so I'm no longer writing the table. Like, this will basically for that specific function in the scope. Like, where is this stored? This is stored in the global scope, and that will have inside that function. There's another scope, isn't it? So for the scope, a new symbol table will be generated, and this will point to that scope table. Okay, or that function basically. And the second thing we'll have, so the get description will be basically the string get description. So this will point, this is the name, and this is the reference pointer, the second cell or the second value or the second element of the each of the rows simply points to the function table. So string get description and person this. So this is for, these two functions are basically for this class person. These two functions are for this class person. And there will be another class is basically for what? The class for the student. The student will have what? Student will, again, it is inheriting. So inheritance of an, ID, address, age, this will be inherited by default. So that means we will be having the string name as n, then we have integer id as NID, and then string address, then we have integer age. However, again, for this student, we will have what? A pointer, which is basically v pointer, points to the vtable for this class. That points to this class. And this vtable will consist of the function, basically the member functions, for this class. So the member functions of this class is basically what? Student class is these three. So the first one is get department. Let me write the get department at the very end. There will be reason. So you like it will be easier to understand. So get department, and the second one being, let's say, get student ID, get student ID, and the third one will get description. Now our question was which get description to execute for the person's one or the student's one. For the get department, we have seen it points to this string description. Sorry, not string, the get department function. So again, this will point to basically to that function. So get department with the parameters as person this. Then we have, sorry, not person this. This is student this. I have made a mistake. I'm really sorry. Most probably, yeah, I have made a mistake here. These are not person. These are student, referring to like these are the objects. Like the student object should be passed here. Sorry. Student. Now, why student? Because see here, like these functions are basically under whom? This student class, isn't it? That's why the student ID, like get student ID, get description, and get department is should be passing the student object as a parameter. So the string get name will have student as the parameter here. So student this. The student ID will have get student ID, and the parameter as student this. Finally, should we point to this function or another function? We won't be pointing to this function, irrespective or despite the fact that we are inheriting the features or the attributes of the person function. However, we have overridden this function by ourselves. Hence, we are going to only point to that function. So get description where the parameter is student this. So when we are calling this basically points to that function where we are only passing student this, which is basically the content of this get description. So if now things make sense, it will be easier to understand now that what happened, we had a class, that class gets converted to actually basic normal data type, and the functions, the member functions also gets like converted to normal functions. However, now we have to pass the parameters of the objects here, which are either person or student types, and this classes will have in the similar manner the structure we have the symbol tables here. So symbol tables will be generated for these classes, and there will be this added point. We need to add this v pointer to the v tables corresponding to the functions of these classes. V tables are basically containing functions for each classes, and the reference to those v tables is considered or contained in the v pointer, which are added to each of these classes. So each of these classes now add this v pointer as a new attribute. And on that v table, we simply have the functions we need to call. Now remember, if we haven't described this function, which is get description, student this, if we haven't overridden this, then what would happen? In that scenario, we would have called this function. If this was not overridden, we would have simply called this function. Now, oh, I also forgot to mention here, there is another function. So there will be another function. Which function? Remember, we inherited some of the functions here, isn't it? So if we inherited all the features, there is another function, like these two functions we inherited. We overridden this part using this function, like this pointer, but we haven't overridden this get name. So there will be another get name, and this will point to basically this get name, if that makes sense. So now, due to inheritance, we do call the parent function here. So this is the parent's function which we inherited. Hence, whenever we have this get name from the student, this will point to the get name function, which is declared basically into the v table of the person class. Okay, so that's basically how v pointers and v tables are managed, and you will see on this on the on the handle there are these 5 points how to actually the five actually steps given how to add these v pointers. Basically, the first one being that you have to add the code how to access the v pointer property. So how to you have to add the code, simply the tree address code how to add these v pointers to each of the classes, how to add them. You simply have to add that. Then you have to call the generic global methods. Like these are the generic global methods. Okay, these are the global generic methods which will take the v pointer reference. So basically, v pointer reference is the v pointer will have, let's say, the sorry, not this one. Generic functions are for calling the functions of the v table. So we will have a, let's say, call v table. We will have a function named v table function, and that v table function will have this v pointer as the parameter, referring to which v table to actually call. So if we have student class, it will place the v pointer of the student class, and it will point to this v table. If it was a person class, then it will have the v pointer for the person class, and it will point to the v table of the person class. And once we are onto that v pointer, we will have access to the member functions in this case. And those member functions will be called by placing the object as the class object as the parameter, and finally the result will be received. In case of inheritance, if polymorphism exists or overriding exists, simply a new function or a member function will be generated for that. If no member function or if no overriding is done, in that case, the parents function will be called from this v pointer. That means this v table, we simply have the reference over here. This cell will have the reference to the parents member function. It won't be having any like new get name member function declared here, because we haven't declared anything. We haven't overridden anything here. We have only overridden the get description function, not the get name function. Okay, so I would urge you to go through the OOP handle provided to you. Then it will be, and then again, if you require, you go through the lecture recording, and inshallah you will be able to understand what actually happened. Okay. Also, in this scenario, we only had one parameter, which was basically the object instance. Now, this could have happened that we have placed more parameters here. In that scenario, what will happen? So let's say in get department, we place the student ID at first as parameter. In that scenario, we will have the first parameter as student as this, and the second parameter as the student ID. So that means the subsequent parameters won't get discarded. Those will be actually added here. Okay. Also here, they will be added simply sequentially. So student ID. So that will actually happen. So we won't actually discard anything. We will be utilizing all the information required. Okay. So if that's understandable, if you have any question, you may ask. Anyone, any question so far regarding to this lecture? Because I know this will be confusing because I tried to cover the whole of the OOP concept in a single class. However, if you go through the lecture handles by yourself, inshallah, you will be able to understand actually what I try to portray here. So try to go through the handle and inshallah you'll be able to understand. The Thursday quiz will be basically based on the theory which we'll be covering today and tomorrow. So tomorrow we will be covering the stacks theory, and today like so we have covered the object-oriented theory. So I'll be asking uh mm, like like one possibility will be I'm giving you like the class sort of instructions and saying if this class member is, let's say, student dot get name is a function. In that case, what will be the equivalent tree address code? What will be the equivalent tree address code? So that could be a possible answer. Now, what will be the tree address code? It is the same as the for the struct we have seen. So the struct will be basically here for the struct, and the tree address equivalent code was basically this, isn't it? So it will be in the same manner. It's the same thing, nothing different. So that's all for today. If you have no question, then let's end the class here. Take care. Allah Hafiz. Assalamu alaikum. Wa alaikum assalam wa rahmatullah.